I will start with the introduction of Green's theorem. Green's theorem is one of the four main theorems of vector calculus, which are all linked together. The self-taught English scientist George Green, who was born in 1793, is the inspiration behind the naming of Green's theorem. In 1823, Green became a member of a Nottingham library and began to study deeper mathematics. Next, there are two different forms of integral that are equivalent according to Green's theorem. The first one is a line integral is converted to a double integral. The second one is a double integral is converted to a line integral using Green's theorem. Then let C be a piecewise smooth closed, positively oriented simple curve having a limited surface, and let R be the area where C bounds, which the formula is integral f times dr equals to integral pxy dx plus qxy dy, where the main formula is double integral delta q over delta x minus delta p over delta y dA. If fxy equals to pxyi plus qxyj be continuous function with continuous first partial derivative in an operation containing R, then integral f times dr equals to double integral curl f k dA. A curve C in plane defines C rt equals to x di plus y dj, which the limit is a until b, is closed and it has two endpoints which have the same value as xa equals to xb and ya equals to yb.
For question number 1, a 53 years old woman with breast cancer become the subject of a study conducted by a researcher. Suppose you are a researcher and a doctor has just sent you a magnetic resonance image of your patient's breast. What is the tumor size? What is the exact area of the red region that the ellipse encloses using Green's theorem? Given by x squared over 4.65 squared plus y squared over 3.5 squared equal to 1. An equation of the ellipse given by x squared over 4.65 squared plus y squared over 3.5 squared equal to 1. Parametric form can be written as x equal to 4.65 cos theta, y equal to 3.5 sin theta, while the limit theta from 0 until 2 pi. By Green's theorem, AR equal to integral x dy. Then we substitute the integral by limit 0 to 2 pi. 4.65 cos theta get it from x, while 3.5 cos theta get it from differentiate of y. And then we put the 4.65 multiplied with 3.5 at the outside. So we get 16.275 integral cos squared theta d theta. And then cos squared theta, we will use the trigonal identity and we get 1 plus cos 2 theta over 2. And then we put the 2 outside and then we get 8.1375 integral 1 plus cos 2 theta. And then we solve it, so we get 651 over 40 pi. Here is the maple comment. We start with restart and then with linear G. Next, we put C equal to 4.65 cos theta and 3.5 sin theta. After that, we need to plot the data. By using maple command, plot open bracket C bracket 1, comma C bracket 2, comma theta equal to 0 until 2, multiply with pi and the close bracket. Next, we enter Q equal to xy 2x, and then we enter A equal to int, open bracket Q, open bracket C, bracket 1, comma C bracket 2, close bracket, multiply with div, open bracket C, bracket 2, comma theta, close bracket, and then comma theta equal to 0 until 2, multiply with pi, close bracket. And lastly, we enter value A and then we get 51.1294244, which the same with the manual calculations.
For question number 2, use Green's theorem to find the work done by the force Fxy equals to 4 6x plus yi plus xy square j, and C is formed by the parabola y equals to 1 over 2x square and the line y equals to 4x. Since C is a simply connected closed curve, the line integral can be evaluated by using Green's theorem. For the manual solution, firstly, we need to know what is the value of Py and Qx. So, from the questions, we know that Py equals to 4 and Qx equals to y squared. So, we just have to substitute the values of Py and Qx in the Green's theorem. So, we get double integral y squared minus 4 dy dx. For the limit y, we just need to take the value from the equation, which are y equals to 1 over 2x squared and y equals to 4x. For x limit, we need to do the simultaneous equation for the y function, and then we will get x equals to 0 and x equals to 8. And then we just do the integral and substitute the values, and the final answer we will get 193024 over 21. Maple command for question 2. First, we need to restart, then with student. After that, we need to put the function, so f equals to map unapply, and put the function from the equation, which is 4 6x plus y xy square xy r1 equals to t 1 over 2 t square and r2 equals to t 4t. Then we need to plot the graph. So plot OPR1 and put the limit for x-axis, t equals to negative 10 to 10, and OPR2 for limit y-axis, t equals to negative 5, 10, and put the color equals to green, red, and axis equals to normal. After the graph was displayed, enter w equals to double integer difference fxy 2x minus difference fxy 1y, and put the limit for the double integral. So y equals to 1 over 2x square for x, and limit for x equal to 0 and 8. And lastly, we need to type value w in order to get the final answer, which is same with the manual calculation.